Alright, in this video we are going to talk about how to traverse a given circle single linked list. So it's basically the same as the single linked list, there is no difference at all. So here we are given a circle single linked list like this. So we have to traverse through this circle single linked list. Now the first thing that we are going to do, we are going to visit node 1 and print its value to the console. Now in our case, node 1's value is 1. Then we are going to continue to the next node, which is node 2, and print its value to the console. Now in this case, node 2's value is 2, so we are printing out to the console 2. Then we are continuing to the next node, in which we have node 3, and then we are printing out value of node 3 to the console, so value of node 3 is 3. Then we are continuing to the last node, which is node 4, and printing out its value to the console. In this case, its value is 4, so it's printing out to the console 4. Now when we reach the last node, we are stopping over here. Now you might be interested, when we reach the last node, it might come to the first node and it might loop infinitely in this case, because from the last node we have a reference to first node. So as you remember, when we are creating circle single linked list, we have created size property. So in size property, we are keeping the number of elements inside circle single linked list. So we are going to use size property to prevent infinite loop in this case, because otherwise we can loop through this circle single linked list infinitely. Now to prevent that case, we are going to use size property of circle single linked list that we created in Java. Now let's see how the algorithm of traversal method looks like. And the first thing that we are going to do, we are checking that if circle single linked list exists or not. So we are doing so if head parameter points to null or not. If head parameter points to null, it means that we have not created our circle single linked list. So in this case, we are printing out message to the console saying that the circle single linked list does not exist and terminating our algorithm. Otherwise, we are continuing to print out current node's value. Then while we have not reached the size of the circle single linked list, we are printing each element's value to the console. Now at the end, when we reach the size of the circle single linked list, we are terminating our algorithm and finishing the process over here. Now based on this algorithm, we are going to create traversal method in Java. So let's head over to Java to create our method. Now here we are going to create our traversal method inside circle single linked list. Now as you remember, we have created create circle single linked list method over here and insert circle single linked list methods over here. Now after insertion method, I'm going to create traversal method over here. Now the traversal method will be declared like this, public void, and it's not going to return anything because we are just traversing through the elements and printing out to the console its value. So traverse CSLL, circular single linked list. So it will not take any parameter because we will loop through the all elements of the circle single linked list. Now the first thing that we are going to do, if head is not equal to null, in this case we can continue traversing, otherwise we are going to print out to the console saying that linked list does not exist. Now in this case, the first thing that I'm going to do, I will create a new node and set the head value to it. So node temp node will be set to head value because we are starting from the first node. Now then I will create our loop like this. So our loop will start from 0, int I equals 0, and it will continue until we reach the size of the circle single linked list. Now this size property comes from the circle single linked list properties. So we are continuing until we reach this size property, and in each iteration we are going to increase I by 1. Now inside this loop we are going to print out to the console temp node's value. So I'm not just going to print out it one by one, so I'm going to create if condition over here to print out it as it is in the linked list. So it should print out proper way, which makes it easier to visualize it. So in this case I'm going to put like this. So that's why in this case instead of print I'm going to use print. So print temp node.value. Then I'm going to put if condition like this. If I is not equal to the size minus 1, then in this case we can print out arrow over here, otherwise we will not print out. So when it reaches the size minus 1, it means that we have reached to the last element. So after last element we don't need to print out arrow over here. So that's why I will put if condition like this. If I is not equal to size minus 1, because at the size minus 1 we have last elements, so after the last elements we don't need to print out arrow because we don't have any element there. But till that, we are going to put arrow between the nodes. So it's going to be like this. So by doing so, we are making our traversal more readable. Then after this if condition, we are going to set temp node to temp node.next, because in each iteration we need to continue to the next node. Then I'm going to print out to the console if the head value equals to null, this linked list does not exist, because in this case we have to say to the user that the linked list does not exist. So I saw this if condition over here. I'm going to put else condition and printing out to the console saying that the circle single linked list does not exist. Now with this we have finished our method. Now let's see how this is working in practice. So as you remember, in our main class we have created circle single linked list like this, and we have inserted 3 elements to this circle single linked list. Now by using traversal method, we are going to see that how these nodes inserted over here and if they are inserted in correct order, and we are going to see that if we are traversing all these nodes over here. Now if we run our code, now you see that our cursor appears over here. Now to prevent this case, I'm going to put a new line character after this loop over here to make our code more visible. So I'm going to put new character over here, println, because in this way we will make our code more readable. So if I run our code one more time, you'll see that cursor will appear after the linked list. So you see that it's more readable now. Now here you see that first we start from 4, then we have visited 6, then we have visited 5, and then we have visited 7. So 7 is the last node, 4 is the first node over here. So when we are creating a circle single linked list, we have created it like this. So we had only one element, which is the first element 5. Then by using zeroth index over here, we have inserted 4 at the beginning of this circle single linked list. So that's why 4 is first element over here. Then by using first index, we have inserted 6 at the second location of the circle single linked list. Then by using 8 index over here, which is greater than the size of the circle single linked list, we have inserted 7 at the end of circle single linked list. So then traversal method visited this node by starting from the first node until we reach the last node. So in this case, the first node is 4 and the last node is 7. So as you see, our traversal and insertion methods works the way that we want. Now let's see what's the time and space complexity for this method over here. Now, as always, we are going to start from the first line of code. So in the first line, we have if condition in which we are checking if head is not equal to null or not. So in this case, it will take O1 time complexity. Then in the next line of code, we have created new node and assigned head value to it. And this is also will take O1 time complexity. Now then we have a loop over here. We are looping through all elements of the circle single linked list. Now in this case, if the number of elements is n, so the time complexity for this loop will be On. Now then we are printing out the value of temporary node to the console. This will take O1 time complexity. Then we have if condition like this, in which we are checking that if I is not equal to size -1, then we are printing out to the console this arrow over here between the nodes. So this means that this if condition also will take O1 time complexity. Then we are setting temp node's next reference to temp node, and this is just simple assignment, and this will take O1 time complexity. Then here also we are printing out to the console new line, and then we are printing out to the console this message in the else condition, which says that CSLL does not exist. So this means that these two print statements also will take O1 time complexity. Now if we combine all these complexities over here, it takes On time complexity, because here O1s are non-dominant terms, so we are going to eliminate them, so it will take On time complexity. Now the space complexity is O1 because here an additional memory is not required to perform this traversal. We are just visiting all elements and printing out their values to the console. So an extra space is not required over here. That's why space complexity is O1. Now with this we have come to the end of this lecture. So in this lecture we have discussed how can we traverse through circle single linked list. So here an important moment is we have used size property to prevent infinite loop. If we have not used this size property and loop through the nodes in other ways, for example using while loop, in this case it's going to loop through the nodes infinitely if we have not provided any condition which stops our loop. So take into account that by using size property, it makes our life easier to prevent infinite loop in case of traversal of circle single linked list. So hopefully everything is clear about this method. So let's continue to the next lecture. So see you in the next lecture.